So before starting the proper chapter, I want you to understand a bit about how current impulses conduct through a tissue and how it is detected. Okay, so this is a piece of tissue. So it consists of cells. Okay, so there are cells above this tissue. So suppose we put two electrodes, a positive electrode here, a negative electrode here. Let's make the positive electrode green. Okay, and a negative electrode here. So you see, you know from physics, right? Ki suppose this is a positive pole, this is a negative pole, electrons will move in this direction. So you say that current moves in this direction. Okay, it's either this, or you can also say if positive ions flow in this direction, then the current is again in that direction. All right, so in the cells what happens, there is flow of positive ions like sodium, potassium, calcium. Okay, so here what happens, your positive ions flow from here to there. Okay, so if positive charge is, so if what happens, so this is a positive pole, this is a negative pole. If a positive charge, if a positive charge flows towards positive pole, then in a graph you will get a positive deflection. Okay, and if a positive charge flows away from the positive pole, you will get a negative deflection. Similarly, if a negative charge flows towards negative pole, you will get a positive deflection. If it moves away from the negative pole, you'll get a negative deflection. All right, I think this much basics should be clear. So here what happens, the ions move. If you take one cell out of this box, so you have read about the impulses and what ion flow changes take place. Basically, sodium comes in and calcium comes in. Okay, so you get the depolarization curve. Okay, so and these sodium and calcium, they go through the cell junctions, and because the cells are in syncytium, so they pass into the next cell and they cause subsequent depolarization. So here what happens, the positive charges are flowing, okay, in the form of sodium, calcium. All right, so in this tissue which is connected to these two poles, so suppose an impulse is conducted here, so this layer of cells become positive. Okay, so in the graph, if you connect this to a galvanometer and the galvanometer is connected to a graph paper, okay, and the galvanometer is connected to a graph paper which is rolling, which is like scrolling at 25 mm per second. Okay, so if the positive charge is moved towards the positive pole, then this galvanometer pointer will deflect. Okay, suppose this is the isoelectric line, this galvanometer, when it is okay, this galvanometer will deflect, suppose in this direction. So when this graph paper will move, you will get, and this galvanometer will move simultaneously, you will get a positive graph like this. Okay, all right, and when the same thing, you'll get a positive graph like this. All right. So the similar things happens if a negative charge moves towards the negative pole, you'll get again a positive graph. And if this positive charge moves away from the positive pole, okay, then you will get a negative graph. Okay, this is how ECGs are made. Okay, if this positive charge moves away this direction, away from this positive electrode, then suppose this current deflection will be towards this direction, then you'll get a negative graph. All right, so this is what happens in a musculature, cardiac musculature.